So building interactive experiences on the web today usually involves sending some JavaScript down to your users, often quite a lot of it. Today we're going to talk about some strategies you can use to deliver that JavaScript efficiently while still giving users a really great experience. So I work on a web browser called Chrome, and when users access your site, you're probably sending down a lot of files. From a web browser's perspective, this looks a little bit like this. It gets even worse with H2 multiplexing. So my perspective is that as much as I love JavaScript, it may be the most expensive part of your site. Byte for byte, JavaScript is probably the most expensive resource you're shipping down to your users today. And I'd like to explain why I feel like that. So the median web page today is currently shipping down about 350 kilobytes of minified and compressed JavaScript. Uncompressed, that bloats up to about a megabyte of script. Now, the experiences that are shipping down this much JavaScript are taking anywhere between 15 to 36 seconds to get interactive on mobile devices. Now, although I've said 350 kilobytes here, the reality is that if we take a look at popular sites, they're actually shipping down a lot more script than this. We're hitting this ceiling across both desktop and mobile web, where sites are often shipping multiple megabytes worth of code that a browser then needs to process. Now, the impact that this can have on loading a web page is some weird and wonderful quirks. So the way that we take a look at loading a web page today is that it's a little bit of a journey. It's kind of like a film strip that has three key moments in it. There's, is it happening? Is it useful? And is it usable? Is it happening is the moment where you're able to deliver some painted content to the screen so the user can actually tell, well, hey, this web page is loading up. Is it useful is the point where you've painted contentful text or something that allows the user to derive value from the experience. And then is it usable is the moment when a user can actually start tapping around the experience and having something happening. So I mentioned this term interactive earlier, but what does that actually mean? Well, for a page to be interactive, it has to be capable of responding quickly to user input. Whether a user is clicking on a link or scrolling through a page, they need to be able to see that something's actually happening in response to those taps and those actions that they're making. An experience that isn't able to deliver on this is going to frustrate your users. Now, one place where this can commonly happen is when folks are server-side rendering their experiences and then shipping a whole bundle of JavaScript down right after to populate and hydrate that experience out. Now, when a browser needs to run many of the events that you're probably going to need, it's probably going to do it on the same thread that handles user input. Now, that thread is called the main thread or the UI thread. If you happen to be shipping down lots of expensive JavaScript, that can end up blocking the main thread. So let's take a look at what you expect will probably happen. So here's an example where, maybe you're going to go and tap around the UI, you might check a checkbox or click a link, and everything's going to work perfectly fine. But if we simulate blocking the main thread, nothing's able to happen at the moment. We're not able to check that checkbox. Any links that we click are not necessarily going to do what we expect because we're blocking that thread. So we want to start moving away from doing those types of things. Now, this idea of JavaScript impacting interactivity is something we're seeing across lots of different types of sites. Too much JavaScript in general can actually delay interactivity for visible elements, and this is a problem for many sites, including Google. So we run into this in sites like Google Search. So here are a few examples where you could start tapping around the UI, but if we're shipping too much JavaScript down, there could be some delay in there before something actually happens, and the user may end up feeling a little bit frustrated. So that's an experience that we want to move away from. When it comes to time to interactive, we feel that you should probably be getting interactive in about under 5 seconds. There's nothing actually on this person's screen here, so they may be going through withdrawal symptoms of some sort. Ideally, we'd love to shift the web to a position where we're designing a little bit more for resilience. Interactivity can heavily impact a lot of things. It can be impacted by a person loading your website on a mobile data plan or coffee shop Wi-Fi, or just them being on the go and not necessarily having a consistent network connection. Now, when this happens and you have a large payload of JavaScript that needs to be processed, they can end up waiting for the site to actually render anything, or if something does render, they can be waiting a long time before they can actually tap around and have something happen. Ideally, shipping less JavaScript would lead to a point where they're not necessarily running into those cases. Now, to explain why JavaScript is such a big deal and why it can have such a large cost, I'd like to walk you through what happens when you send content down to a browser. So A user goes and they types in an address bar, types in an address into their Omnibox, their address bar. A request is made out to a server, which will then have to return some markup. The browser needs to parse that markup and get out the CSS, the JavaScript, the images that are necessary. And then the browser actually has to process all of those resources. This is actually an accurate depiction of what happens in Chrome when we're trying to process everything that you send down. Now, although this looks great, one of the challenges here is that JavaScript can actually end up being a bottleneck. So ideally, we want to be able to paint pixels quickly and then have the page interactive. But if JavaScript's a bottleneck, you can end up just looking at something that you can't actually tap around with and experience. So we want to move away from JavaScript itself being a bottleneck to modern experiences. One thing to keep in mind as an industry is that if we want to be fast at JavaScript, we actually have to be fast at downloading that script, parsing it, and compiling it. That means that we have to be fast at the network transmission side of things, but also the processing side of things for our scripts. Because if you're spending a long time parsing and compiling script in a JavaScript engine, that can delay how soon a user can interact with your experience. Now, to provide some data about this, here is a breakdown of where V8, the JavaScript engine in Chrome, actually spends its time while it's trying to load up a page containing script. So in the orange, we have all the time being spent parsing the JavaScript the popular sites are sending down. In yellow is the time we spent compiling. And together, these take up anywhere up to 30% of the time it takes us to load up the JavaScript for your page. This is a real cost. Now, another thing to keep in mind with JavaScript is that all bytes are not equal when it comes to the web. 200 kilobytes of script and 200 kilobytes worth of image have very different weights. They might take the same amount of time to download, but when it comes to processing, we're dealing with very different amounts of costs. A JPEG image needs to be decoded, rasterized, eventually get painted on the screen. A JavaScript bundle needs to be downloaded and then parsed, compiled, executed. There are a number of other steps that an engine needs to complete. Just be aware that these costs are not quite equivalent. Now, one of the reasons why these costs start to add up and matter is mobile. So mobile itself is a spectrum. Many of us here today probably have a high-end or medium-end phone. And the reality is that our users may not necessarily have those device classes. They may be on a low-end phone, they may be on a medium phone, and the disparity between these multiple classes of devices can be quite stark. Due to thermal throttling, difference in cache sizes, CPU, GPU, you can end up experiencing quite different processing times for resources like JavaScript, depending on the device you're using. So here's a breakdown of how long it takes to parse JavaScript from a range of different types of devices. At the very top, we have high-end devices, which generally process it pretty quickly. At the very bottom, we've got our low-end devices, and in the middle, we've got our average phones, so things like the Moto G4 or the Moto G5. Now take a look at how much longer that script takes to process. We can actually try to look at a more practical version of this. So here is the JavaScript startup time, processing time, for CNN.com's JavaScript. On an iPhone 8, using the A11 processing chip that they have, it takes 9 seconds less to process JavaScript than it does an average phone. 9 seconds. That's 9 seconds quicker that experience would be loading and interactive on an iPhone than something more average. This hints at another thing, that maybe we need to stop necessarily taking fast networks and CPU and high RAM for granted. Fast devices can actually sometimes be slow. You can be running multiple things on there. Fast networks can be slow. Variability can end up making absolutely everything slow. You may have users that, are not going to have the latest and greatest phone. They might have something more average. And so it becomes really important for us to start testing on real phones and real networks. So if your team are able to take a look at their analytics and understand exactly what devices your users are actually accessing your site with, that'll give you a hint at what devices you should probably have in the office to test out your experiences using. If you're not able to afford those, or just can't get approval for it, check out webpage test/easy. We have a number of profiles set up there that you can go and use today that already have popular devices pre-configured. We've got some median mobile devices like the Moto G4 already in there. And it's also really important to test on representative networks. Now, although I've been talking about the notion of low-end and median phones being important, Brian Holt made this really great point yesterday, which is it's really important to know your audience. Not every single site needs to work great on 2G on a low-end phone. You may well have a wide range of users on sort of the higher end of the spectrum or in a different part of the spectrum. So just be aware of the data behind your site so that you can make a reasonable call on how much all of this matters. So if you want to be fast at JavaScript, download times are going to be pretty critical for low-end networks. The things you can do there are just ship less code, minify your source, take advantage of compression, so gzip, Brotli, Zotfly. Take advantage of caching for repeat visits. Parse times are pretty critical for phones that have a slower CPU. Now, on the server, if you're sort of a back-end developer or a full-stack developer, you know that you kind of get what you pay for with respect to CPU, disk, network. As we build sites that are increasingly more reliant on JavaScript, we sometimes pay for what we send down in ways that we don't always easily see. So the shape of success there is, what can we do to send the least amount of script to our users while still giving them a useful experience? Now, one of the useful things that you can do to accomplish that today, one of the greatest tools in your tool belt, is code splitting. So code splitting is this idea that instead of shipping down your users a massive JavaScript monolithic bundle, sort of like a massive full pizza, what if you were to just send them one slice at a time? So the smallest amount of script that they need just to get the current page useful enough for them to use. Now, code splitting can be done at a page level, at a route level, at a component level. And this is something that's well supported by many modern libraries and frameworks. It's well supported in Webpack. So consider code splitting. It's not this sort of theoretical thing either. Many large teams have been seeing really great wins off the back of investing in code splitting recently. So both Twitter and Tinder, as part of rewriting their mobile web experiences and trying to make sure that users are able to interact with their sites as soon as possible, saw anywhere up to a 50% improvement in their time to interactive just by adopting aggressive code splitting inside their experiences. Another thing that many of these sites have done is adopted auditing as part of their workflow. Thankfully, the JavaScript ecosystem has got a number of great tools here. So things like Webpack Bundle Analyzer, which allows you to scan, using the source maps of your scripts, all of your dependencies that you're including in your bundle, and it helps you identify sort of those places where you have libraries that are perhaps larger than you thought they might be. You might have npm installed yourself into some performance problems just because you needed to ship something and include a date library or a UI library that was a little larger than you thought it might be. Also great for spotting places where you're including duplicate code. So just take advantage of some of these tools for auditing. If you're really unsure whether you have any issues with JavaScript performance in general, check out Lighthouse. So Lighthouse is one of those tools by the Chrome team that we've baked into the Chrome developer tools. It's also available as a Chrome extension. And the idea here is that it gives you this really in-depth performance analysis engine that will highlight places where you can be doing better. One of the things we recently shipped in Lighthouse is a feature called JavaScript's boot up time. This allows you to highlight places where scripts might be spending quite a long time in parsing and compiling and executing. So you can try to look at opportunities to either split up those scripts or just be doing a little bit less work there. Another thing you can do is try to make sure that you're not shipping unused code down to your users. Something that's also baked into Chrome developer tools is code coverage. Code coverage is really useful because it allows you to just load up your site inside of Chrome, and then you can start interacting with your pages, and it'll highlight all of the code that's actually been used or unused on a per script level. And as you start interacting, it'll actually update in real time those different bars to show, in red versus green, how much is unused versus used. This can be really great for identifying opportunities to split up your scripts, or in some cases, maybe not even load them up on initial load. Maybe they could be deferred till a later point in time. So taking a look at production examples where some of these ideas have been useful, I was talking to the Netflix team last week, and they mentioned that there was this point where when you landed on Netflix.com, they had a non-member landing page flow that they wanted to optimize. They were initially using React on both the server side and the client side, but they wanted to make sure that their time to interactive was as good as possible. And so what they ended up doing was actually dropping React just for the client-side portion. We're still using it on the server side, but they prefetched it for subsequent navigations deeper into the user experience. This improved their time to interactive by 50%, which is huge. It meant that users could sign up a little bit quicker, and it was worth the time investment here. Another thing that Netflix mentioned was that there was a point where they were trying to move their video playback component, so the component that you see whenever you're trying to play anything on Netflix, from vanilla JavaScript over to React. So this was the identical UI, for both versions of this thing, and they experienced some negative results initially. They found that the extra JavaScript costs for downloading, parsing, evaluating, and the runtime costs for using virtual DOM diffing were quite high. And that ended up causing a few negative results, so reductions in play hours, reductions in usage. And so they ended up needing to spend a little while actually reducing these costs to enable them to finally roll out React for the video player too. I wanted to highlight what this actually looked like. So here we have an example using vanilla JavaScript where there was no interference on the main thread, so you're interactive pretty quickly. And then we have a busy main thread example where all of that JavaScript processing meant that it took a few seconds before the user could actually start interacting with the video player. As I mentioned, they're thankfully in a much better place now, and they've been able to ship out this experience to users. But keeping an eye on their time to interactive and their JavaScript costs was critical to them enabling future experimentation that used React. Now, if you're looking for a pattern for serving JavaScript efficiently to your users, I heavily recommend checking out Purple, or PRPL. So Purple is a pattern that stands for push, render, precache, and lazy load. And it's a pattern for aggressively code splitting, where you just ship down the code a user needs for every single route. And then you take advantage of Service Worker for pre-caching the JavaScript and logic needed for future routes, and lazy load it as needed. What this means is that when a user ends up navigating to other views in the experience, there's a good chance it's already in the cache. And so they experience much, much reduced costs in terms of booting this up and getting interactive. So we've talked about a few ideas. If you care about performance, if you've ever worked on a web perf patch for your site, you know that sometimes you could end up working on a fix, coming back a few weeks later, and someone on your team may have been working on a feature or unintentionally, broken the experience. You could be in a position where you just fixed the site, and someone comes along, and you're like, why did you ruin it? Why? Thankfully, there are ways that we can try to work around this. And one way is having a performance budget in place. So performance budgets are great because they keep everybody on the same page. It creates a culture of shared enthusiasm for constantly improving the user experience. And it holds the team accountable. Performance budgets can be employed at sort of a file size level. So you could have, budgets based on JavaScript chunks. You could have budgets around speed metrics, so time to interactive, or other metrics like first contentful paint. This is an idea that is well supported in tools like Speed Curve or Calibre. And so if you're interested in trying to get performance budgets set up, there are a number of tools you can try out just to roll this out for your team. I heavily recommend it. If you're interested in trying to track the cost of JavaScript in production for your real users, there are two things I'd recommend checking out. The first is the long tasks API. So this is an API that we recently shipped in Chrome. It allows you to gather real-world telemetry on parse and compile as well as culprits. Basically, long tasks are any task that lasts longer than 50 milliseconds that could be problematic on the main thread. And you can record that and log it back to your Google Analytics. Another thing to check out is first input delay. Now, this is a metric that measures the time from a user first trying to interact with the experience and the browser actually responding with something. So this is still an early metric. We actually have a polyfill available for it today that you can go and check out. But between these two, you should hopefully be able to get enough telemetry from real users to understand what JavaScript performance problems they're running into. So improving performance is a journey. It's generally not something you're just going to do, all in one go and be done with. It's usually a journey where a lot of small changes can actually lead to pretty big gains. I don't expect most people, especially if they have JavaScript performance problems, to go out and fix everything tonight. I try to compare this to the experience that you might have if someone asked you to learn how to sketch out something, like a baby, for example. If someone told you to go and learn how to draw a baby, you'd probably look up a tutorial, and maybe the first step would be drawing, the outline. The second step is probably drawing the rest of the baby, but that's not the expectation I have of everybody here. What you probably will do is, make a few incremental improvements to your experience. Maybe you'll chip away a little bit at the JavaScript, and you may end up here, which is actually, not a bad place to be. It's a little bit better than the first one. But over time, if you're able to continue investing in improving the JavaScript performance of your sites, making sure that you're able to get interactive really quickly, your users will thank you because they're actually going to be able to do things much, much more quickly. So I hope some of that was useful. That's it for me. Thank you.